So, with no further ado, I give you Dr. Peter Everts.
Thank you.
Thank you.
Thanks for the introduction. Jill, you're so far away. Thank you for organizing this. I'm happy to be here. The first question is, who has been using PRP at all? What does it mean? Why is it? You have you or you haven't? We just want to wave.
I'm a nurse and I work with Dr. Livnat, and yes, we are using PRP.
Good, perfect. I've been working with PRPs. I did my first case in 1991, and we learned a lot. I do not want to say I fell in love with it, but I started to realize that we, in those days, were at the forefront of something that could make a difference at some stage. And keep in mind, in those days, PRP was mainly used in OR settings. The use of PRP or any other biologics in offices was just simply not thought of, not done, not appreciated. So the whole circus with PRP started in ORs. And they started in orthopedic surgery, they started thereafter in cardiac surgery, and then it evolved only the last 10 years into offices. So, since not all of you have been using PRP, I'm going to spend a couple minutes on the definition, on the starting points. So, in your textbooks from a long time ago, most of you will recognize the main components of blood, what's it all about, what's in it. And I tell first-time clinicians, so if you want to understand what sequestration of blood is, then just take a syringe, do a phlebotomy, just tape it on a wall and wait for 45 minutes, 60 minutes. And nature will do what it shows you in the picture here. It will start to level out the various layers. And that's exactly what we're doing with devices on the market as well. What we're going to do is we're going to build these layers from plasma, a layer which we call the buffer coat and the red cell pack. That's exactly what we're doing with these devices. And the procedure by itself is actually pretty simple, so to speak. We get the blood, access to a blood vessel, we'll discuss it in a little bit more, and then all of a sudden you will have access to platelets. And platelets by itself have been, are these Jill, are these the old slides or the new ones?
No, these are all the new ones.
The new ones, perfect. So when the platelets are finally available for therapeutic indications, you will have availability to a lot of structures. So platelets by itself, they have a lot of different structures in there, from growth factors to cytokines to chemokines. And in the early days, when we started to look for platelets, the main objective was to manipulate with the platelets in order to get the growth factors out of the platelets which are stored in there. And this just gives a simple representation of the growth factors that are inside the platelets. And each of these growth factors have specific functions. And the good thing about nature is there is a relationship with all these growth factors that we have in the body. And what we do with PRP is we're going to manipulate with it a little bit. So we're going to have higher concentrations. That means we need to understand how these individual growth factors will work together. And at some stage they will not work together. These are the old slides. I'm missing a lot of slides. No, they're forward? Now these are the old slides. Because that's why I was asking, I'm missing quite a...
2 minutes,
Keep talking, good. Well, I'm Peter Everts, I'm from the Netherlands. I moved to Florida last year. I got a great visa from the Labor Department. I can work, is he back? I can work here for quite a bit. I live on the other coast. It's a beautiful area down there. We go out a lot. The beaches are perfect. What's that?
Tell us about Amsterdam.
Amsterdam, here we go. Amsterdam, yeah, the city of darkness and the city of joy. No, it's fun. No, I sent Jill another presentation. I was missing a couple slides because I just want to make sure we're on the same page with regard to definitions. The whole thing with PRP is there are so many different products on the market. Up until now, we have about 29 different devices you can choose from. And when we try to call for standardization, at least we should understand, well, what we're getting into. So we have different devices and they all produce a different PRP. We can categorize them. We can categorize them to the product they are producing, which is fine, which should be done. But you have any idea what's in the PRP? What would you like to manipulate? You have been using PRP.
Yes, sir.
What would you like to manipulate? What would you like to control in your PRP substance?
Well, I would like to get a high concentration of platelets and a very low concentration of RBCs.
Keep on talking.
And then activate the platelets to release the growth factors.
Okay. What about the white blood cells?
The white blood cells, I will take them.
You will take them?
Your slides come up, to keep going.
Keep talking, I'll keep on pushing the slides.
The slides to move
Good. So, quit. Yeah, so you want to have all the white blood cells in there? You want particular ones, or?
Well, I would prefer to have the T lymphocytes if I can. I'm not quite sure how to separate it from the neutrophils, but
Interesting. So you don't want to have neutrophils in your PRP?
I prefer not to.
You prefer not to? Good. So where you want to go? Back and
Says to keep
Keep
going.
going forward. I think we just put some, yeah.
Ah, it was
going.
duplicate.
there you go.
Sorry, guys.
We'll talk later. Because the biggest mistake you can make is in the beginning of every procedure. And not many physicians or MAs pay attention to it. What really is important, what is the starting point of your PRP, is a proper blood draw. If you forget about it, then you can say to your patients, we need to do another tap, or you come back next time when I have somebody who can do a proper blood draw. Because it hasn't had so much attention, but what you would like to have is access to a blood vessel from which you can put in a needle that gives you a nice runoff, a nice flow. And most likely, you would like to have a place. You come on up front, sir. Want to take pictures? So what you would like to do is take a peripheral vein, because depending on where you take the blood, you will have different levels of platelets. So that's very important. And one of the other most important things is the blood draw, the time it's going to take, and how you're going to preserve the blood components when you do the blood draw. In other words, we studied platelet counts and how long it's going to take before you're done. So depending on the amount of volume you need to have a certain time, a certain runoff to collect all the blood. The longer it's going to take, the more platelets you're going to lose. So, word of advice, make sure that you have a proper access to the blood vessel, and don't suck on the syringe to create a lot of negative force, because the platelet is the most sensitive cell we have in the human body. When you start to pull that syringe to get blood out of it, you rupture the platelet membranes, and all the good stuff is already somewhere in the plasma and will not be used for any regenerative purposes. Well, good thing is we've seen all this, and this is what I was looking for. Platelets by itself, they have a lot of other different structures in there, And they all are responsible for making your therapies work. So if the objective would be growth factor therapy by itself, that is nice, but with that platelet structure, with the damaging of what you are doing, the lysis of the platelets by itself, you will have more cytokines, chemokines, proteins as a total to deliver to your tissue sites. So again, we've seen this. We get platelets, and they have growth factors, and all of a sudden, at some moment, they are responsible, and it says here neovascularization. But that's not quite a normal thing to happen with platelets, because to get to the level where the objective of a therapy would be neovascularization, you need to have a load of platelets. You need to have a lot of platelets. And that really makes a big difference in what kind of a device you're using, but we'll get to that. Again, in platelets, different growth factors, different functions, they work together. And in fact, what you are doing with these therapies is you take healing to the next step. You're going to take blood from a patient, put it in the machine, get the platelets, and all of a sudden, something is going to happen. Either you add thrombin to activate it, like the gentleman just mentioned, or you just wait, because tissue by itself is well known to trigger platelets to the level that they ultimately will stick together. They will going to adhere, and they're going to lyse, and then we have that all the content of the platelet will surface outside of the platelet to the tissue structures. So this is an animation out of my book, and what I really showed you is, as we sit here, platelets are just circulating in our vascular system. Nothing is going to happen. They are what we call in a resting state. For some reason, they get all these trigger points on the platelet. Like you cut your finger, the platelet will know, they will start a response. They will start to develop what we call these so-called pseudopods, these arms. And the function of these arms is to catch another platelet. And when that happens, they open up. That's the end game of the platelet. In other words, they start to lyse their entire content outside of the platelet. They throw out the entire content into the extracellular matrix. Still, nothing is going to happen. So what we're looking for here is the next step. And the next step would be that the individual platelet needs to find its dancing buddy. It needs to find its dedicated receptor. When they find that receptor, they're going to connect, and then it's what we call, in biology, we have intracellular signaling. And from that intracellular signaling, you will ultimately be able to restore tissue function, whether it's nerve, whether it's soft tissue, whether it's bone. We discussed very briefly white blood cells, one of the most underestimated components in PRP. We get 5 of these different white blood cell types. 2 of them will not survive any machine like the basophils and the eosinophils. And then the discussion really starts. That's why I was asking, what about white blood cells? Do you want them? Don't you want them? And the fair answer is, in some cases you want them, you need them, and in some indications you really do not want them. So we're having discussions, leukocyte rich and leukocyte poor, which already I think we need to leave that discussion. We need to be more specific, and we can, because we need to discuss certain white blood cells. We need to discuss neutrophils, we need to discuss lymphocytes, and particularly monocytes, because they're all very specific. Then, when you're working with PRP, or you would like to start working with PRP, I wish you good luck in making a choice for any of the devices on the market. I did study with my team, others did studies, and again, this is just an example from data we collected using different machines, and not to a surprise, without having proper standardization in place, all these devices produce different platelets, concentrate, different composition of cells, so it's going to be very difficult to understand what kind of device you would like to have. In other words, what's the objective of your therapy? So if you're into sectional wellness, if you're into erectile dysfunction, you maybe would like to have a different PRP than when you are in wound healing. Because we got different tissue types, we got different pathologies, we got different goals to achieve in order to overcome erectile dysfunction, in order to make that wound close. So these things you need to keep in mind when you're working with. In other words, not all PRP is the same. And especially with regard to one of my favorite cells next to platelets being the monocytes. They've been very much underestimated, but they play a very key role in regenerative processes. Their flexibility on transforming to macrophages, supporting other healing processes. They have non-pro-inflammatory capacities. They have regenerative capacities just by having different type of macrophages available. And all these devices, they are differently constructed. They give you a different composition of white blood cells, and therefore a different composition as well from the monocytes. Like I said, on the right side, we get about 28, maybe 30 devices that are already on the market, and they give you different kind of PRP. I'm just showing you this picture. This is not PRP. I've seen physicians sticking in a needle, have some kind of a vacutainer, and that's their basis to produce PRP. You're shaking your head. Why are you shaking your head? What's that? You can't believe it. Trust me. People use this as a basis. And we just heard a story that was told last week that having 10 mils of whole blood will give you a 5 times concentration over baseline in platelets. You're really going to believe that? You're serious about this? That's really a sham. That's really, without discussing, well, the two by itself, this is really something we need to come up with and find a way. Because what are the facts? What are the facts of PRP looking back? We don't have many robust systematic reviews all over the use of PRP. We simply don't have them. We notice that the literature sometimes gives you different results. Some of them are good, some of them are bad, and we need to understand why. And the information, like Elizabeth said, is pretty clear. When you dig in deeper, you will understand it. The other thing is, we never gave it attention. That's why I mentioned specifically urology, sexual wellness, as the aims for treating these patients are different than from an orthopedic surgeon. So we need to take into account, you need to take into account when you choose your PRP system, what kind of a PRP system would you like to have? What are my goals? How I'm going to treat what kind of patient, what kind of tissue type. So this is going to be very important. And then physicians are still looking in a discovery phase as what they are doing. But listen, PubMed, June 12th, we get almost a hit on platelet-rich plasma, getting to 10,000 published articles. This year, already, we are more than half of the total from last year. So there is an interest, and there's for sure something going on with PRP. We only need to tailor it down, and again, I support the thought of standardization. This is just a summary of where PRP has been used in different medical fields. And as you can see, the objectives per medical field, per be prepared as clinicians to anticipate on it. And as well as how am I going to deliver it? I can make a graft out of it, I can make a spray out of it, I can inject it directly in a joint, I can inject it, I can do the combination with adipose tissue, and I can use it again in combination with other products like plasma and PRP, and you can use it in combination with shockwave therapy, which is one of the major themes for tonight. I'm almost done, 2 more slides. When you start to understand this slide, you know at some stage the choices you need to make for a certain system. What does this slide show you? We concluded we get a lot of growth factors in platelets, right? We know we have different pathologies, we have different tissue structures. But for every of these indications, we have to find that optimal concentration in order to make a clinical significant difference in outcomes. And that's something we are getting closer to understand. How much platelets do we need to close a wound? How much platelets do we need to overcome erectile dysfunction? And I would like to introduce, just to make it even more complicated tonight, I would like to introduce a new term, clinical PRP. Clinical PRP, think about it. Because what's happening, we have different kind of PRPs on the market. Out of these 10,000 published papers, we have PRP that can be lab-based medium. There are studies in tissue engineering where they add PRP into the medium in order for cells to proliferate and differentiate better. We get in vitro cell culture PRP. We get PRP for small animals, and that PRP for small animals is more difficult than for larger animals. The truth is, what we really would like to have is clinical PRP. We would like to have PRP that ultimately will give us a minimum of platelets for you to work with. So when you have that magic syringe after the procedure, you're going to inject it in anywhere tissue. You need to have at least 1 billion platelets per milliliter in order being able to influence biological processes. And you might be able to just inject 1 mil, or maybe 2 mils, or maybe 4 or 5 mils, but you need to have that guarantee what you are injecting in any of the tissues. Because only then the literature reveals that you're able to influence proliferation, differentiation, chemotaxis, all these fancy names in order for tissues to heal. And the other thing you would like to have is a variability on protocols. You would like to have variability on red cell contamination, specific white blood cells. Maybe you do want to have neutrophils. When you work with bone tissue regeneration, you do want to have neutrophils. You want to have that full pro-inflammatory process for bone to further develop. So we're going to discuss over the next year more clinical PRP. What is clinical PRP? So in order we have that distinct answer made. That's it for now. Thank you so much. Do I take questions now?
So if you do have any questions, we're sort of segmenting this out, because I wanted to be interactive, and we also are very new to it. No questions is no question. Please ask away.
Sure.
Hi. Hello.
That's good. You're good.
I don't think. Does
The mic's actually for show, but that's what we talked about. So we can hear back here if you will, Maria.
for every ml that's being drawn, does the patient's total platelet make a difference? So, for example, when we do blood work and we're looking at platelets, and my platelets happen to be higher than someone else, will that 1 ml or whatever's drawn produce more? So, I guess my question is, for every ml per person, can you guarantee that you're getting the 1 billion platelet counts? Because someone's platelet may be lower for...
Correct.
So do you do blood work first to determine, okay, they have the range that we're looking at to...
Give me the mic for the show. That's a good question. What's that?
That's a great question.
Yeah, that's a very good question. The 1 billion came out of normal healthy donors, which have normal platelet concentration anywhere from 150,000 to 350,000. When you do pre-lab work and you find patients who have 100,000 or even less, the next question we need to ask is, because those patients have been walking around with a low number of platelets forever, when they injure themselves, they will heal. Maybe the receptors, maybe the intracellular signaling is used to the lower concentration of platelets. We have, however, no data from whatever work, whether in these kind of patients, we will have the same angiogenetic properties at lower levels. So on average, for the 80% of patients that fall within that same category. To get to that 1 billion, you need to be able to increase from baseline with any device at least 6 times baseline. So some of these devices, they're not going to make that 1 billion based on the construct and based on the discussion we had of having a test tube that's going to give you any number at all. Sir.
So, follow up on that question. No, they can hear me. Mathematically, in order to achieve the concentration of 1 billion, what would be the amount of blood that we have to draw to reach that concentration of 1 billion per cc? And normally we use more than 1 cc. For instance, I use between 5 and 6 cc's for my procedures.
Good. So again, it really gets back to the definition of your PRP protocol and the PRP device you are currently using.
I use the outside.
Good. Then depending on the kit you are using, you should be able to get that 1 billion easily with any of the kits, whether it's the 30 mil or the 60 mil. The good thing about doing studies is, which we do a lot right now, and which we all support by what was mentioned by lab work, is that you get data, but these data confront you as well with your own practice as how you prepare your PRP. And sometimes the little tweaks in preparation, like if you use it, you will recognize it, to get to the level where you have that red flare entering that syringe. That may be 0.2 mils of aspirate at that moment gives you that difference of 4, 5, or 6 times the baseline. So from a methodology speaking, it ultimately with the M-site system, it really relies on your technique as how to produce it. That's the main thing, but anywhere with a normal range of patients, you should be easily get that 1 billion per milliliter either.
Is it practical for any clinician to actually do a platelet count on the final product? Because we don't have the ability to do this in our offices.
Well, I hear you, and if you have the ability, there will be machines on the market soon. There are already little lab devices on the market. There are just platelet counters on the market. But it's a matter of time that that kind of quality control will be inside offices, needed, supported, governed, whatever you want to do it. So you better prepare for it.
Thank you.
Anybody
And
else?
Dr. Bush is going to be presenting some data on that, and just, that's really interesting, right?
Perfect. Thank you.
Thank you.